Hello and welcome class. So in last class we started the new chapter force and laws of motion, and in last class we learned what is force and what is balance force. Okay? Let's recall it once again. What is balance force? If a object is in state of rest, you are applying one force in this direction, other force in opposite direction, but the magnitude of force is same. So there is an object and you are applying force from two direction, okay, and the magnitude of force is same. So what is happening here? This object is not changing its state. It was in motion. I have applied two opposite and equal force. The object is still in rest state. So those forces which are applied on an object in an equal and opposite direction in such a way that the state of that object does not change, then that force is known as balanced force. And if two forces are applied in equal and in opposite direction, but the magnitude of forces are not same, one force is greater than other force, then what will happen? The object will change its state. If that object is in rest position, that object will start moving, so it will come in motion. So that type of force is known as unbalanced force. Is it clear, class? So we were understanding unbalanced force by an example that there is a cart made by some childrens, okay, and the children is pulling this cart with a force F, okay, and this cart is on ground. So, children is pulling this cart with a force F, and because this cart is in contact with a ground, so there exists a friction force which will try to stop this object. Friction force. I am donating friction force with the symbol small f. Now let assume that children is trying to pull that cart and unable to pull that cart. What does it mean? It means that friction force, the magnitude of friction force is equal to the magnitude of the force applied by that object, that person. That's why this object is not changing its state. Okay, the friction force arises between two surfaces in contact. Friction force always arises when two surfaces are in contact and one surface is in motion. Okay, so the contact surface is this. The two surfaces are the bottom of this cart and the ground, and between bottom of this cart and ground there is a force exists between them. That is a friction force between the bottom of the box and the floor of the rough surface. Friction force balances the pushing force, therefore the box does not move. If this I am applying force, but this object is not moving, okay, it means the friction force is equal to the applied force but in opposite direction. That's why the state of this object doesn't change. The children push the box harder, but the box still does not move. This is because friction force is still balancing the pushing force. So this force F, and there is a friction force. If applied force is less than friction force or equal to friction force, the state of the object will be rest. Okay, I am applying force on this pen. Okay, this object is not moving. Okay, because the friction force is greater than my applied force. I have to apply force with the magnitude more than the friction force in opposite direction, then this object will change its state. So No matters how hard force you have applied, if your applied force is less than or equal to friction force, the object will remain in rest state. If the children push the box harder, still the pushing force becomes bigger than the friction force. If you apply a force greater than the friction force, what will happen? Then there will be an unbalanced force and the box will start moving. If you apply the force greater than friction force, then the object will start moving. So we got the motion state. Now, what happened when we ride a bicycle? When we stop the pedal, the bicycle begin to slow down. Okay. Have you ever ride a bicycle? You have noticed that if you stop pedaling, the the bicycle will begin slow down. Why it is so? Because at every time there is a friction force between the surface of a tire and the road, and friction force is trying to oppose the motion of bicycle, and that's why after few times when you stop pedaling, the bike begins to slow down. Okay, so why the bike becomes slow down? Because of the friction force acting opposite to the direction of motion. In order to keep the bicycle moving, you have to start pedaling again, otherwise the bicycle will stop after few times. It is thus appear that an object maintain its motion under the continuous application of unbalanced force. So from the example of bicycle, it is clear that in real world there is a friction force, and if you want any object to do motion continuously, you have to apply an unbalanced force. It means a force greater than friction force. However, it is quite incorrect. Okay, it is quite incorrect. There is a condition that a object move with uniform velocity when the force of pushing force and friction force acting on the object are balanced. There is no net external force on it. If any object, okay, is moving in such a way that the value of friction force and value of applied force is balanced, okay, and the velocity is uniform or constant, velocity is constant, it means there is no acceleration. If any object is not accelerating, the velocity of that object is constant, or in other sense, the F net, the net force, which will be the force applied minus friction force, is zero, and that object is in uniform motion because the object has velocity constant. Okay, you do not have to apply any unbalanced force on it to keep that object moving. Okay, so there is a condition, an object which is moving with uniform velocity, it means that object is not accelerating, or in other sense, the net external force, okay, applied force minus friction force is zero, and that object is in uniform, having uniform velocity, then you don't need to maintain a unbalanced force to keep that object moving. Is it clear, class? If an unbalanced force is applied on the object, there will be a change in either speed or in the direction of the motion. Thus, accelerating the motion of an object, an unbalanced force is required. If you want to change the speed, the direction of the object, it means you are accelerating an object. To make any object accelerate, you need to apply an external unbalanced force. Okay. This was the example of uh, children's pulling a cart and friction force is applied in opposite direction. And if your applied force is lesser than or equal to friction force, this object will be in rest state. If your applied force is greater than friction force, then this object will be in motion. Okay, so we have understand that if any object has uniform velocity, then that type of object can do motion continuously. It means if any object has net force equals to 0 and that object is continuously moving, then it will never stop. That type of object never stops. Okay. By thinking about it, we have made first law of motion. By observing the motion of object on an inclined plane, Galileo, a scientist, deduced that object moving with a constant speed when no forces act on them. He observed that when a marble rolls down an inclined plane, its velocities increases. Okay, in the next chapter, in the gravitation chapter, we will learn that any marble or any object fall under the unbalanced force of gravity and it rolls down to attain a definite velocity by time, which is they attain a acceleration to reach the bottom. Okay, so if you have made a inclined plane and you let a ball roll from here, you will see that this ball will get accelerated, and at the lowest point its velocity decreases and this object will move continuously. If this bed is frictionless, okay, if the floor is frictionless, this object will move continuously. It does not require any external force. All the net forces are zero, no external forces acting on it. Friction force is zero. Then this object will keep moving. Okay, it will not stop. Galileo argued that when the marble is released, it would roll down the slope, go on the opposite side with the same height. If you are able to make a slope here also with same height and same width, then this marble will roll easily on the marble will easily roll on this incline and reach the highest point from where it began if there is no friction involved. If the inclined plane on the both side are equal, then the marble will climb the same distance that cover while rolling down. The marble will reach, okay, same height. Okay, if the marble begins from here, it roll down, it moves up, it will reach the same height. This height and this height would be same, will be same, okay, if there is no friction. Okay, it means that the marble is exerting a constant, is exerting no net force. F net is zero. Okay, and it has attained uniform speed, so it keeps rolling. And if you attach a inclined plane here, okay, this marble will reach the same height from where it begins. The angle of inclination of the right side plane were gradually decreases. If we decrease this angle of inclination, okay, if we start decreasing, it means we are making this slope less slopey. If we started decreases, then the marble will roll back to its original height till the distance to its original height. If the right side of plane were ultimately made horizontal, if this side is made horizontal, it means there is no inclination, then this marble will travel continuously forever. Okay? Nothing can stop this marble if there is no friction force involved in it because F net is zero. We haven't applied any force and there is no friction force and the marble is rolling. So there should be nothing to change the speed of this marble, okay, because it has already got an unbalanced force. And to change the state of the motion, we need a unbalanced force. And this marble has no force, so you have to apply external force to change the state of this object. The unbalanced force on the marble in this case are zero. There is no unbalanced force in on this marble. It thus suggests that an unbalanced force is required to change the state of the motion. This ball will remain continuously in motion because there is no friction force involved in it. Okay? If you want to change the state of the motion, it means that if you want this marble to come in rest state, you have to apply an unbalanced external force. In practical situation, it is difficult to achieve zero unbalanced force. That was a theoretical situation where we are saying that surface is frictionless. But in practical situation, there is very difficult to achieve a zero unbalanced force because of the friction force. This is because of the presence of the frictional force acting opposite to the direction of the motion. Thus, in practical, the marbles drop after traveling for some distance. The effect of frictional force may be minimized by using some smooth marble, some smooth plane, or provide a lubricant on the top of the plane. We can try to achieve the zero unbalanced force situation by making the marble smooth, by making the surface smooth, or by applying the lubricant on the top of the plane. But it in practical it is very difficult to achieve zero frictional force surface. So what we are doing, this is an inclination, there is a marble, okay, and we release this marble from the top. What the marble will do? Marble will fall down because of the gravitational force and it will keep moving. Okay. And if you made, okay, this is first inclined plane, this is second inclined plane. If this marble has started from this point, this marble will reach the ground, travel some distance, and if there is no friction, then this marble will again reach this maximum height from which height it begins, okay, then fall back and then return back on original position and it will continuously oscillate. Okay, if you change the angle of inclination, if the angle of inclination is more than the original inclination, the height will be lesser. If the angle of inclination is equals to the angle of inclination before, then height will be equal. If the angle of inclination is less than the previous inclination, the height will be maximum. And if the inclination is zero, then this marble have achieved a net zero state, okay, and this marble will be in motion forever if there is no friction force present there. Okay, this was all the observation made by Galileo. Another scientist, Newton, further studied the Galileo's idea on the force and motion and present the three fundamental law that governs the motion of objects. Newton, a scientist, studied the observation of this Galileo inclined plane observation, and after observing this state, he has given three laws of motion, and we are going to learn about these three motion laws of motion in this chapter. So there are three laws of motion, okay? And what does first law of motion stated? The first law of motion stated that if an object remain in the state of rest or in the state of uniform motion in a straight line, okay, an object will remain in the state of rest or in the state of uniform motion in a straight line unless and until we have applied any external force that changes the state. Okay, so it means that what does this law stated? If an object of mass m is in rest position, so it will continuously stay in the rest position unless and until you have applied external force to change its state, or if that marble which was going forever, okay, a object which is doing uniform motion, okay, is in motion, and you want to change its state, you have to apply an external force to stop it. So the change in state occur when you apply an external unbalanced force on that object, and this is the first law of motion, that an object remains in the state of rest or in the state of uniform motion unless you have applied an external force on it to change the state of that object. So you have to apply an external force to change the state of motion, rest or motion. In other words, all objects resist a change in state of motion. This is the simplest form of first law of motion, that all the object resist a change in state of motion. If any object is in motion, it wants to stay in the motion state. And if a object is in rest state, then that object wants to stay in the rest state. They does not want to change their state. If you want to change its states, you have to apply force. In a qualitative way, the tendency of undisturbed object to stay at rest or to keep moving with same velocity is called inertia. So we have learned about a new term which is inertia. Okay, it is the property or tendency of the object to stay in their same state. And this tendency is known as inertia. If this pen is in rest state, it wants to stay in the rest state. Okay, if I have to make it in the motion state, I have to apply force. So the tendency of this pen to stay in its rest state is known as inertia. Okay, so first law of motion explain inertia. That's why the first law of motion is also known as the law of inertia. The first law of motion is also known as the law of inertia because first law explains inertia, a property of any object to in their uh, stay in their state, rest or motion state. So certain experiences that we come across while traveling in a motor car can be explained on the basis of law of inertia. So we are going to explain you law of inertia by some example. Okay, suppose you are sitting in a bus. Okay, you are sitting in a bus and the bus started. So what will happen? Your body will move backward. Okay, this generally you have experienced. Or if a bus is going on and driver suddenly hit the brake, okay, your body will move in forward direction. Why it is so? And the answer is because of inertia. And the explanation is that when you are sitting on a bus, okay, bus is in rest state, your body is in rest state. You also have the property of inertia, that if your body is in rest state, It wants to stay in that same state. Okay, and if you want to change the state, you have to apply the force. So the bus is in rest state, you are also in rest state. Okay, if the bus moves suddenly, your legs are touching the floor of bus. Okay, if the bus start moving suddenly, your leg will move with bus, but your body is still in the rest state. So your body is still there. So you feel that you have moved in backward direction. And what happened when the driver hits the brake? Okay, it happens uh, because of inertia. Suppose bus is moving, okay, and driver suddenly hits the brake. Your legs are touching the surface of the bus. So if the driver hits the brake, the bus stops, your leg stops, but your upper body is still in the state of motion. That's why your body uh, moves in forward direction. So this is a small example of inertia. Okay. Now let's understand inertia by an example of a motor car. We tend to remain at rest with respect to seat, okay, until the driver apply the braking force to stop the motor car. With the application of the brake, the car slows down, but our body tends to continue the same state of motion. Okay, you are sitting in a motor car, front seat belt on, okay, and what that motor car is in motion. Okay, the driver applies the brake. Okay, the because driver applies the brake, the car will slow down, but our upper body will be continue in this state of motion because of inertia. And when driver hits the brake, your body will move in forward direction. A sudden application of brake may thus cause injury to us by the impact. Okay, this is little information about Galileo Galilei. Galileo Galilei was born in 15 February 1567 in Pisa, Italy. Galileo, right from his childhood, has interest in mathematics and natural philosophy. His father, Vincenzo Galilei, wants him to become a medical doctor. According to Galilei, enrolled himself for a medical degree at the college. This is the picture of Galileo Galilei in the University of Pisa in 1518, which he never completed because his real interest was in mathematics. In 1586, he wrote his first scientific book, The Little Balance, La Balanciata, in which he described Archimedes, another scientist's method to find the relative density or specific gravity of substance using a balance. In 1589, in his series of essays, De Motu, he present his theory about falling object using the inclined plane. Okay, using this inclined plane, he actually explained the theories about falling object. In 1592, he was appointed as a professor of mathematics at the University of Padua of Republic of Vienna. Okay, he continue by observing the theory of motion, theory of his study of inclined plane and the pendulum formation, formulated the correct law for uniformly accelerated object that the distance of the object move is proportional to proportional to the square of time taken. Galileo explained it, okay, for any accelerated object. And Galileo was also a remarkable craftsman. He developed a series of telescope. Optical performance was much better than the other telescope available during those days. So Galileo actually discovered telescope. Around 1640, he designed the first pendulum clock. In his book, Starry Messenger, on his astronomical discoveries, Galileo claimed that he has seen mountains on the moon, okay? Which was later known as that moon has lot of crest in it. So his this theory was also correct. He has seen the mountains on the moon by using the telescope. The Milky Way made up of tiny star, he explained, and four smaller body orbiting Jupiter. He also see the planet Jupiter and he find out the four moons of the Jupiter. In his book, mm, Discourse on Floating Body and later on the sunspot. Okay, so we all know that in our sun there are three dark spots, which we called as sunspot. Okay, was first seen by Galileo Galilei, and he discovered the observation of the sunspot that the cycle of the sunspot is 11 years. Galileo Galilei actually explained it. This is the small information about Galileo Galilei. And using his own telescope, and though his observation on Saturn, Venus, Galileo argued that all the planets must orbiting the sun, not the earth. In older time, it was said, mm, some scientists like Copernicus told us that earth is the center of the universe and all the planets are revolving around the earth. But Galileo Galilei, by using his telescope, argued that all the planets are revolving around the sun, not the earth, and contrary what was believed at that time, okay, or collision with the panel in front. Okay, this was all the information about the Galileo Galilei. In next, so today's class is over. In next class, we will explore more about first law of motion, okay, and more about inertia and try to answer some basic question which happened in our daily life. I hope this class is clear to all of you. Now we will meet in next class. Thank you.